All right, friends and neighbors, it is time for CCNA Chapter 22, Implementing Basic OSPF Features. Before we dive in, if you like what we're doing on the channel, if we're helping you on your journey, give us a like and subscribe. It really helps us out. But now it's time for some OSPF features. So in this video, of course, we'll do the key topics, and we'll see that today we're going to expand our OSPF topology. Our exam section is still the same one. We're talking about IP connectivity, determining how a router makes forwarding decisions by default, right? So without us messing around with anything, what does a routing protocol do? How does static route work? Things like that. And we did a single area OSPF v2 topology last time, and we're going to expand that, as I said. We're also going to add a couple things to our toolbox. So we're going to talk a little bit about loopback interfaces and the router ID. And we'll finish up with the "Do I know this already?" questions. So our key topics this week will be the organization of the OSPF v2 configuration within the network command. What we're going to find out is that you can build an OSPF topology using the network commands, or we can use interfaces. We're going to do them both. We'll talk a little bit about OSPF wildcard masks. They're different than net masks. They can be a little confusing. And then we've got a whole bunch of OSPF verification commands. We'll do a bunch of them in the video. I'll try to remember to do them as many of them as we can. And then we've got a couple of neighbor states we'll talk about. And then rules for setting the router ID. And so we'll futz around with a couple of ways that happens. Some are automatic, some you can configure. And then again, we'll run through a bunch of the OSPF commands to verify our config and to see what we can learn from them. Now, if you remember last time we did our OSPF single area topology, and our basic commands were this, right? We give interfaces their IP addresses, and then we dove into the OSPF configuration. And the key thing for us here is that we use what was called the network command, along with a wildcard mask and then the area to build our OSPF topology, right? And the minute we did that, the OSPF routers started communicating. Well, we're going to add the loopback interface because routers select an ID, but life is different in the face of having a loopback interface, and we can configure the router ID in OSPF. And so what ends up happening is the router will select one automatically, but it might not be the one that you want. So we'll fool around with that. And then again, we're going to hit a bunch of wildcard masks. I'll give you some thumb rules for wildcard masks, and we'll do a couple of examples. All right, let's look at our topology and then add the loopback interface. All right, here is the topology that we were working with in the last video. We've got 1, 2, 3, 4 networks out here, and we have a couple of OSPF routers talking to each other. Now, if we take a look at our router 1 here, our upper left, and we do a show IP route, we can see that we've got a couple of routers talking to each other. We have the 11 net and the 12 net. Those are directly connected. And then we have one OSPF neighbor that's out here. And I have not yet configured this router down here because we want to see what happens. Now, the key idea here is that we're going to mess around with the router ID, and I'll show you why. If I take a look at two things, the first is our running config, right? And we can see that right here is how we configured OSPF, right? Just the interfaces just have their two IP addresses, and then we've got our network commands. That's the key this week. We're using network commands here, and we're going to migrate away from that. So this is a very traditional way to set up OSPF. Now, show run is one thing that we can use to see what's going on. I can do a show IP route to help me troubleshoot or verify my config, and we can see right here that I am missing the 14 net, which is our bottom network down here. Okay. Now, what we can also do when we're running OSPF is run OSPF specific things. We can say show IP route OSPF, right? We might just see just the routes that are OSPF. So if I had a large routing table or I was trying to focus, I could do that. But I can also do show IP OSPF. Whoops, that out of the way. OSPF neighbor. And I can see that there's another IP address. I'm getting messaging from 10.1.12.254. That's this interface right here. But I'm getting this neighbor ID. And at this point, I might go, who is that? All right. Well, let's work a little bit on our router config in our lower router. All right. So what I'm going to do is go into my lower router here, and I'm going to say, we're going to run our network commands, and I'm going to do 10.1.12.0. Now here's our wildcard. And of course, we're going to do area 0, like this. But I'm also going to do the 14 net, just like this here. Now the minute I do that, right, the routers are now engaged with each other. And we can see loading to full, so that's a happy thing. Now, what is my neighboring router going to see? Well, let's do a couple things. If I do a show IP OSPF neighbor, I can see that I use this crazy address right here. So here's the thing to remember about router IDs. By default, a router will say, I want to use the highest active interface for my router ID. But you can also specify what you want to use with the router ID command. Lastly, if there's a loopback active, then no matter what the loopback address is, the router wants to use the loopback as the router ID. So the loopback is considered a management interface. So if on this node I wanted to do a router ID with a loopback, what I would simply do is interface loopback 0, for example. And I might say my IP address for my loopback interface is, I don't know, 8.8.8.8. Now this has nothing to do with my actual configuration. But if I take a look at my running config, I can see that I now have a loopback interface. Now the nice thing about a loopback, it's sometimes considered the management interface, is that it is reachable from any direction. It's not tied to a physical interface. It also has an effect on what your router understands or thinks it understands. So if I do a show IP route, the loopback interface is also in my routing table. Okay, now by default, because I have a loopback interface on this router, my router will want to use the loopback interface, but I already had an OSPF process running. So now if we look at the router that's all the way on the other side of the topology, right? Router 0 here. What does it think is going on? It believes that it's got a neighbor at this ID, but wait a minute, I just specified that on our other router here, I would be using a loopback. Shouldn't it pick the loopback? Well, the problem is that I already had an OSPF process running that was already loaded. If I wanted to utilize the new addresses, I would have to either clear the IPOS process or do a reload. So I'll do that here in a second. But if we compare what's going on here, so the router picked an address that was existing, it would have been the highest active address on this router here. So now if I say clear IP OSPF process, now you might not want to do this on a production router, but there we go. So now we're going to reset, and what we will wait for is for it to load to full. Okay, so we can now see some of the loading that was done, and if I do a show IP OSPF neighbor, whoops, we can see that now it's taken on this loopback interface address as the router ID. So the nice thing is that you sort of know that if you bring a router up, it'll take the highest IP address as the router ID, but it's not always clear when you're looking at other routers where that IP address came from. So you bring up a loopback and it automatically wants to pick that one. Now you might have more than one router ID associated with, or more than one loopback associated with your router that you want to make the router ID. And so what you can do is you can use the here, we'll do it over here on the other router where we set the loopback. Let's say that I had more than one loopback. What I might do is say router ID, and in this case I would want to use 8.8.8, but there we go. So you can use that command to enforce your decision. So that would be the syntax right there. Okay, so that's a loopback and a router ID and sort of the order of selection of the router ID value. So what are these crazy wildcard masks that we've been seeing? Well, they're not the same as a network mask, but they're a little more flexible. It's a different logical operation. So remember, with net masks, we have an ANDing process that we do. And so what a net mask does is, if you think of a net mask and you break it out to binary ones and zeros, we know that anything ANDed with a zero gets ignored. So you can put any value there and it gets ignored. Well, wildcard masks are the exact opposite. So anything that matches up with a 1 is ignored. Now, the nice thing is that where net masks have a very strict sort of rules, right? They can only advance one way or the other along that 0 and 1 boundary. You can use any values that you want in a wildcard mask. Now, like net masks, there are some special values. So where a 255, 255, 255, 255 net mask is a match to an exact IP address, the same mask in wildcards would be 0.0.0. So you would match a particular IP address. Now the opposite is also true, whereas a net mask of 0.0.0.0 matches everything or cancels out everything. A wildcard mask of 255, 255, 255, 255 doesn't care about anything. So it either wipes out everything or matches everything, depending on how you want to think about it. Now you saw when I was doing networks, you can break them easily across A, B, and C classes. So a class A wildcard mask would be 0.255.255.255. Class B would be 0.0.255.255, and so on. Now I mentioned you can have some crazy patterns, right? So the one on the bottom of the slide here says, oh, I've got this 192.168.1.64, but the wildcard mask of 255, 255, 255, 254 matches almost nothing. In fact, the only thing that it cares about is that there's a 0 in the last bit of the IP address. In other words, it only likes even numbers. So that's what I mean when I say that you can use any crazy pattern in wildcard masks that you want. You just have to be aware of the IP addresses or the patterns that you want to match. Now here are a whole bunch of commands to help us verify what's going on with our OSPF configuration. And these all start with the idea that, remember, that OSPF goes through a series of phases or states. And the first thing that we talked about last week was that two-way configuration. Two routers come up and they find each other. They're trying to figure out their neighbor relationship and then maybe an adjacency. So they figure out their neighbor relationship, and that's that two-way stage or two-way state. And then you start to learn about each other's databases. That's the flooding of the LSAs. And then finally, everybody's got the same link state database. We begin to populate the routing table and figure out what we're going to put in the routing, or which routes we're going to choose. So there are, as you can see, a pile of commands. I've got my cheat sheet here next to me, so I'm going to try and go through a few more of these when we do the rest of our demo. So let's take a look at that. So we'll work with our friend router number 1 here. And we'll start with, we just did a show run. We'll do a show IP route, right? We know now that we've got this loopback interface that's here, and now we've got the OSPF routes, so we can see that. But what I might also do is a show IP protocols. This is another sort of general command that we have, and we can see, oh, all right, I've got the OSPF is my current process. So I know that not only am I doing this OSPF protocol, but that I'm talking to some other routers. Here are the networks that are involved, at least from this router, and some of the folks that I've been talking to. So that's another way to sort of understand what's going on. We can see the administrative distance here for OSPF is 110, and that I'm using the default value. We can also see this in routing table entries, where there's our administrative distance, and this is the OSPF metric. Why is it 2? Well, if we take a look at the 13 net, from the perspective of router 1, the 13 net is over here. Well, we're going to go out 1 gigabit Ethernet interface and a 2nd gigabit Ethernet interface to get there. So the metric for an outgoing gigabit interface is 1. So we go out 2, so it's 2. The same is the value, or the value is the same for 100 megabit interfaces. Well, what else can we learn from our router here? Let me see what else I got on the list. We'll do, oh yeah, let's do this one. We'll do the show IP OSPF database. All right, so when routers pass through neighbor and they are now beginning to exchange link state database content, we can see that, again, I've got the router link states, right? Again, who am I talking to? The areas, how long have I been, how long has this message been in the database? But this shows really sort of everything that I have from the perspective of this router. This is this router's database. And I guess because we're going to do a couple of ways to do OSPF configurations, we could do a show IP OSPF interfaces. These are interfaces that are working within OSPF, and we can see right here that we've got a router ID, we've got a broadcast type of network, and so these are details about my configuration. There's our hello interval, the dead interval, and then we've got our next interface down here. So these are the interfaces that are engaged in OSPF. So there we have it. There's a couple of ways to verify our router configuration. Now the states, of course, are really going through those phases of those states. We go from two-way, we get a link state database, and then we get to full, which we saw when we were loading. And then, of course, you could have a role that's a designated router, you could be a backup designated router, or you could be neither. You could be a DR other or a druther. Implementing multi-area OSPF. Now, as we said before, you can get an awful lot done with a single area OSPF topology. So one area is plenty to handle small to medium size, right? Low complexity networks. But at some point, the number of networks you have, the number of different organizational structures, or the complexity, security concerns, all of these may necessitate moving to a multi-area OSPF topology. Now, in that case, what we're going to do is just specify that some networks are going to be part of a different area. So you know the network command that we've been using so far. We've got network, the network value itself, the wildcard mask, and then the area. And all we're going to do is manipulate that area. Remembering that if I designate one router interface to be working with a particular area, anybody else connected to that network should also use the same area. We always start with area 0. All other areas connect to area 0. So you would never connect area 1 to 2 to 3 to 0. It would be all of them would just be connected to area 0. Now we can also create areas or OSPF configurations with interface commands. We'll do both of those right now. So here we are in our single area topology, as you may recall. And what I'm going to do is I'm going to say I want this portion of the network to be a different area. Now what this is going to mean is that where this is area 0 up here, I'm going to make this area 51 down here. That also means that this router number 2 here, is now on the border of 2 routers. In other words, or the border of 2 areas. In other words, it is an area border router. Now the way that we do that is by modifying this config a little bit. Now I don't have to do a whole lot, and I'll remind us about what our configuration is now. So right now we have everybody in area 0. So what I'm going to do is remove the 14 net from area 0, and all that I'm going to do is negate the command. So I'm going to say no network 10.1.14, oops, area 0. So that's all that I'm going to do. So now I don't have it in there, but what I am going to do now is add it right back in, but I'm going to say that you are now area 51. So that's all that I'm going to do. So now if I take a look here at my show IP OSPF database, we can see that I now have information about both areas. So router link states in area 0. So all of this is information about area 0, right? Everybody that I know that's in area 0, or all of my information that's in area 0. And then what I'm going to do is say, well, here's the stuff for area 51. Now this also means that there will be summary LSAs. Remember, previously routers were communicating their link state database with link state advertisements. And so far we've talked about 2 of them really, the network LSA and the router LSA. And now we're going to add the summary LSA, which is what we do the minute we have multiple areas out there. Well, let's see what our neighboring routers believe is happening on the OSPF topology. Well, let's do a show IP route to start. And here's our change right here. We see that we have an OSPF route, but all of a sudden it's an inter-area route. Now, nothing else changed. The admin distance didn't change. The metric didn't change, right? The network is still located in the same way. It's just an inter-area route, so I don't have to worry about it in my area database. Okay, so that is one way to configure OSPF routes. So again, if we take a look at our config, what we've done is sort of a traditional configuration using one-stop shopping, right? Our router process, and then all of our OSPF information is right there. And this is sort of considered traditional because one of the other ways that we have to work with OSPF is on the interface or the sub-interface command. So I can do all of my OSPF configuration right there. So what I'm going to do now is eliminate my OSPF configuration. I'm going to say no router OSPF1. So that just kills that process on this particular router. So we'll verify that it's gone, right? So we have no OSPF configuration. Now we look at, maybe what we'll do is reset everybody so we don't have to wait for the timers. Right? If I take a look at it still thinks these are here. So what I'm going to do is clear IP OSPF process again. And what we'll find out is that we won't be able to load anything from our lower router because, well, it's not there anymore. It's not participating in OSPF. So now what we're going to see is that we're missing a part of our configuration, right? The 14 net is gone. It's beyond that other router. Well, the first thing that I'll do is we'll go into our router here and we'll say, well, look, I want to participate in OSPF. And the way that we might do that is going into our interface G0/0. Now that is this one right here. Maybe we'll label that for you. Right here. And this is G0/0/1. Okay. So now what I'm going to do is I'm going to say IP OSPF. Now, again, I'm on the interface now. What can I do from here? Oh, look at all of these OSPF commands. And all that I'm going to do is say, here's my process ID, and I want you to be part of area 0. And all of a sudden, I will now pop up as a neighbor where I didn't before. There we go. So now we're loading to full with my neighbors. So again, now the routing table for this router here will not have changed very much because it already knew about all of the networks that we're working with, right? What will change is that it suddenly understands that it's got another OSPF neighbor out there. Okay, so we understand that we've got this here. And here's another really good example. 14.253 is not in the game at all as far as OSPF is concerned, but we can see that our lower router has chosen this as a router ID. So this might actually be confusing if you were trying to understand what went on. And so again, we would use the loopbacks. So let's see how we can bring that router full into the game now. Well, what we want to do is two things. We want to use the interface subcommands, but we also want to do multi-area. So now what I'm going to do is go to the other interface, and I'm going to say IP OSPF process 1, and then we're going to say area 51. Now we might do the same thing, right? We might clear the process to get everybody to make this happen very quickly. So we know that they know about their neighbors. So they should be, the minute we had the communication previously, they were communicating, so they should do link state updates between them. But let's take a look at the routing table to see if it's updated yet. It has not, so we'll give this a minute. And here we go. Now that they're talking, we can again see that we've got our inter-area route via our southern router, or router on the bottom. So there we have it. That is two ways to configure multi-area topologies. It's actually two ways to work with OSPF in general, right? We can either use the network command, which is one-stop shopping, where everything is configured together, or some folks might find it a little bit easier to go into the interfaces that they know are connected to other OSPF routers and configure everything on OSPF or for OSPF on the interfaces themselves. All right, did you know this already? Question number 1, which of the following network commands following the command router OSPF1 enables OSPF on interfaces whose addresses are the following? So this is very similar to question number 2, except this value right here, we're looking at that second octet, right? And they look the same, but take a look at the answers. They reference the 10 net instead of the 10.1. So we got to be really, really careful with that one. So answer to question 1 was 10.0.0.0, and then the wildcard mask was 0.255.255.255, which would capture all of these because it doesn't matter what went on in the last 3 octets. This is as opposed to the answers that were here that began with 10.1, and so we needed a different wildcard mask. Which of the following commands list the OSPF neighbors off interface serial 0? Well, there were 2 of them. You could just do a show IP OSPF neighbor, or you could just say show IP OSPF neighbor and then serial interface or serial 00. Both of those would work. Now, when you reload, and this was the router ID question. So you had to know for this question how you choose a router ID. So the question says that there's a couple of interfaces that are active, and some of them are loopbacks. So the key here is that you're going to pick a high IP address, and you're going to prioritize loopbacks over physical interfaces. So in this case, the highest loopback was 10.8.8.8. The other ones were not loopbacks. Even though they were higher, they were not chosen. The other key here is that there was no router ID command. Router ID command overrides everything. Question number 5, an engineer migrates from the traditional configuration that uses the network command. So that was the first way that we did this. Instead, to use the OSPF interface commands. Which of the following commands configures the area assigned to an interface? Well, we just saw that when you go into an interface, you do IP OSPF, then the process, and then the area. The nice thing is you don't have to worry about the network ID in that case. So question number 6 is similar, right? We're going away from the OSPF network command, and we're going to do it per interface. Which one of the commands, which show command identifies whether an interface has been configured with the OSPF process ID? Well, if you go and you now do the show IP OSPF interface commands or show IP protocols, which will show the interfaces that are involved, those two will give you the details you need about the interfaces. There you go. So our chapter 23 look ahead, we're going to push our OSPF configurations a little farther. Actually, both 23 and 24 are OSPF, but each time we keep building on what we're doing. So we went from single area to multi-area. We went from all defaults, now we're using a router ID, now we're using loopbacks, and then we again said, well, are there 2 ways to configure this, right? Networks or going into the interfaces. So here we're going to add a couple of additional things for our configuration. And when we get past OSPF, it's time for IPv6. All right, how about those OSPF builds? We did verifying our configurations with lots of commands. There's lots of them available to you, and it'll take you through all the states, but even if you're in steady state, you can get all kinds of information via those different commands. Of course, we moved from a single area to a multi-area, and we did it 2 ways. We did it with the network commands, and we did it with the interface commands. And of course, we added router ID configurations with the loopback interface. So all very, very good stuff that applies in other routing protocols too. Well, like and subscribe if you're no longer afraid of areas. May those packets always reach their destinations. And hey, this is OSPF via CCNA. You can do this.